Now guess what this episode brings for all of you? Okay, so I don't want to give you any time for too much of contemplation or apprehension, but serving to the best of your anticipation, I have got for all of you today the hallmarking and the beginning of the season 3 of Is Pharmacology Difficult podcast. And that is the Once Upon a Time series, which will be covering a lot of historical aspects of the drugs and the scientists which are quite famous in the history of pharmacology. Welcome all to Is Pharmacology Difficult podcast. I'm your host Dr. Radhika Vijay, MBBS MD Pharmacology, and this is the audio hub to get the best simplified basic tips, strategies, methods and lots of ideas to learn better, understand better and make your concepts crystal clear. If you really find and if there's a question hovering in your minds, is pharmacology difficult? Lend me your ears for a while and let in the magic of knowledge. Well, in today's Once Upon a Time series, we are going to cover about mainly 3 scientists, maybe a few more, but in detail we'll be covering 3 scientists and their contribution in the neurohumoral transmission. Now, as we study in pharmacology, in the beginning we study the basic concepts, the definitions, but then we have to go for the autonomic nervous system. And when we are going for the autonomic nervous system, that is the basic system, that is the spine of understanding all the systems in the pharmacology. So, the historical aspects begin from the autonomic nervous system, though they may begin much before that. But what I'll be starting today is the contribution of many famous scientists in the neurohumoral transmission series. And after covering in a quite story format and the different important milestones in the end of this series, with a few episodes that will be streaming till the International Podcast Day, that is September 30th. Then finally I'll be giving you the timeline, and that's gonna be a special episode that I'm just giving you a clue about it, no more details. Let's begin. The concept of the neurohumoral transmission, it marks its beginning after the twisting of the 20th century. Now, independently, I again repeat, independently, 2 researchers, namely Langley, and the full name is Sir John Newport Langley, and another researcher was Lewandowski. So both of them, Langley and Lewandowski, they independently concluded quite similar observations, and the concept that was discovered was a kind of connection between the administration of the extracts of substances derived from the adrenal glands, and once the substance was administered inside the human body, it was followed by the sympathetic system stimulation. So this particular fact, it was independently observed by Langley and Lewandowski. Now that's one of the stories. Coming over to the next aspect, it would be quite interesting story-like trail of discoveries while we get to know in the comprehension of neurohumoral transmission. Well, what's more after this? In the 1900s, that is earlier 1900s, so Langley's observation was no less significant. He also observed that there was a release of epinephrine-like substance in very minute quantities from the stimulated sympathetic nerve fibers, which were while in contact with the effector or the action sites. Understood? That's a quite simple concept. That is, he also further discovered that a certain kind of substance, which is epinephrine kind of substance, that was released in very small quantities from the stimulated sympathetic nerve fibers which were in contact with the action sites. Now this particular discovery, or rather we should say observation, it was a kind of a hallmark step in the process of neurotransmission. It was one of the major chemical steps. Now this involved the chemical aspect. Added to this was the observation of consistent and continuous response of the effector sites to the extracts of the adrenal medulla even after the nerve degeneration. So what was the difference in the initial and this concept? Initially it was observed that any extract of adrenal medulla would sympathetically stimulate the nerves. But now it was observed that even if there was nerve degeneration, the effector cells or the action sites would actually produce a response to the adrenal medulla extract. That was quite surprising, right? Now this made further contemplation forced upon Mr. Langley, who suggested the presence of receptors. Yes, he was the first one who suggested the presence of receptive sites and also their dual nature. Dual nature means the duality of excitation and inhibition. So these receptors, they were either excitatory or inhibitory, which were found on the effector organs or sites. So that was the great historical aspect which was contributed by Sir John Newport Langley. Now, before we jump to the next historical story or aspect, I would like you to know something about Sir John Newport Langley. He was basically a British physiologist and he's known as one of the fathers of the chemical receptor theory. He marked the receptive substance concept that I already explained. He coined the term autonomic nervous system, yes, abbreviated as capital ANS in 1898. He thoroughly described the parasympathetic nervous system as one of the basic divisions of autonomic nervous system in around 1921. So that's all about Sir John Newport Langley. Let's jump over to our next historical story or aspect. Now Dixon in later 1900s, he was quite in the research field involving the relations of the muscarine. And what is muscarine? Muscarine is basically an alkaloid and a vagal stimulating substance. So there was a kind of relationship between the muscarine, which is an alkaloid, and also the vagal stimulatory responses. Now what did he do actually? He proposed the further phenomena of the release of muscarine-like substance from the vagus nerve, which was also a chemical step, a very important chemical step in the nerve impulse transmission. At the same point of time, on some other place, acetylcholine and choline esters, their actions were observed and studied in depth by another scientist, that is Reed Hunt. So today I'm not covering much details about the scientist Reed Hunt, but I'm going to talk about Dixon, and I want to let you know more details about Sir Dixon. So I hope you understood the contribution of Sir Dixon in the historical aspect of nerve impulse transmission, the relationship between the muscarine and the vagal stimulation, and the release of the muscarine-like substance from the vagus nerve. That was his major contribution. Now, let me tell you a little more about Mr. Dixon. Sir Walter Ernest Dixon was a British pharmacologist. He was also a fellow of the Royal Society. Actually, he was awarded with the Order of the British Empire, that is abbreviated as capital OBE, in 1919 for his contributions during the First World War. So whatever discoveries and whatever his researches, they were around the time duration of the First World War. So that is why he was awarded the Order of the British Empire. So that was the brief details about Sir Walter Ernest Dixon. Now we'll come over to the next historical aspect. In 1914, Mr. Dale, he carried forward with the studies and behavior of the action of acetylcholine and choline esters. Now what did he do actually? Dale demarcated the important points and the characteristics of the muscarinic and the nicotinic nature of the acetylcholine actions. Well, you should know importantly that Dale is credited with many observations and remarkable achievements in the field of neurohumoral transmission. He also coined the term parasympathomimetic to describe the significant effect of acetylcholine on parasympathetic system and nerves. For the timing, I'm just covering the initial contributions of Dale. There are many later contributions which I'll be covering along with the system. That will be also a part of neurohumoral transmission, but I'm covering a part of the Dale's contribution today, not all the contributions. Now, Dale also discovered the termination of action of acetylcholine. He observed it very deeply. Wonderfully, by Dale, it was seen, and he propounded the extremely short half-life of acetylcholine. And he thought that there was some esterase substance which was responsible for this fact that would quickly break or hydrolyze the acetylcholine into acetic acid and choline esters. Got it? So these were some acetylcholine choline ester related contributions of Dale. Now Dale in fact clearly observed and distinguished that the choline esters responses, they were either muscarinic or nicotinic in nature, and this was actually a consequence of the pharmacological entity or dosage form or the preparation that was being administered. Now there are a variety of organs that are innervated by autonomic nervous system via the craniosacral nerves. Now there was a direct connection between the administration of muscarinic and the stimulation of nerves within these organs. It was actually a great observation which made Sir Dale to suggest the acetylcholine and related esters as the principal neurotransmitters, yes they are, of the autonomic nervous system, that is ANS. And nevertheless, the dual action of acetylcholine and related esters was also suggested by coining the terms like nicotine and muscarine. So Dale also coined the term nicotinic and muscarinic. That is also one of the greatest contribution of Sir Dale in the history of pharmacology. But later there are evidences also we have. Discovery of blocker was a strong supporting feature in this theory. And what were the blockers that were discovered? Atropine was discovered. Tubercularine was discovered. They could antagonize the nicotinic and the muscarinic actions of acetylcholine and related esters. The two types of receptors, they were identified, and there were strong evidences in support of the theory of Mr. Dale. So it's a big wonder and surprise, the theory and observation of Dale. It was derived from very limited resources he had actually. It was derived from crude plant alkaloids, from the plants like Amanita muscaria, Nicotina tabacum. These were the plants. He derived their extracts and did his whole research work. And what is the greatest wonder? The greatest wonder is the present day classification of cholinergic receptors. It follows this age-old concept. It has been a guiding light in the discovery of many subtypes of the nicotinic and muscarinic receptors. So hats off to Sir Dale. Now a little brief account of Sir Henry Hallett Dale. Yeah, that's his full name that I have not taken till now, but you should be knowing it by heart. Sir Henry Hallett Dale was an English pharmacologist and physiologist. He received and he shared the Nobel Prize along with Sir Otto Loewi, that we'll be talking about later, in the year 1936 for the identification of acetylcholine as an important chemical neurotransmitters and also the related concepts and theories. So that was all in today's episode and the Once Upon a Time series, episode 1 of season 3. I hope you all enjoyed these stories and these historical, great, wonderful discoveries, observations, and a little insight into the scientists. So let me know your comments and your thoughts about this particular season and series that we have started in the honor of the International Podcast Day 2023, that is September 30th. That is how we are celebrating it. For all the updates and latest episodes of my podcast, please visit www.pharmacologydifficult.com, where you can also sign up for a free monthly e-newsletter of mine. It actually contains a lot of updates about medical sciences, drug information updates, and my podcast updates also. You can follow me on different social media handles like Twitter, Insta, Facebook, and LinkedIn. They all are with the same name as Pharmacology Difficult. If you're listening for the first time, do subscribe and follow whatever platform you are consuming this episode. Stay tuned. Do rate and review on iTunes, Apple Podcast. Stay safe, stay happy, stay enlightened. Thank you.